Hey guys, tonight we're going to step away from the noise, the endless scroll, and the constant demands of the world. We're going to dim the lights on the great, frantic stage of human existence and turn our attention to the quiet drama playing out inside you, right now. Imagine it. Inside your skull, a universe of silent electrical flashes, a galaxy of thought and feeling, all working tirelessly while you listen to the soft rain outside, or maybe the hum of a distant refrigerator. Tonight, we're going to talk about something you almost certainly take for granted: your nervous system. Not the part that makes you jump at a sudden sound, but the quiet, deep, and ancient part. The one that works while you're asleep, while you're daydreaming, even while you're reading these very words. It's a universe so complex, so intricate, that if you truly understood it, you would likely not survive the sheer weight of its beauty and terror. So, before you get comfortable, take a moment to like the video and subscribe. But only if you genuinely enjoy what I do here, and if you're so inclined, tell me where in the world you're settling in tonight and what time it is for you. We are all connected by these quiet moments, no matter how far apart we are. Now, let's begin our journey, not with a bang, but with a whisper. Our story begins in the most unassuming of places, a single neuron. This tiny cell, barely visible under a microscope, is the fundamental unit of our nervous system. Think of it not as a brick, but as a miniature self-contained universe. It has a star at its center, the cell body, or soma, where all the essential life-sustaining processes occur. Sprouting from this star are a multitude of tiny branching rivers called dendrites. These are the receptive antennae of the neuron, reaching out to listen for messages from thousands of other neurons. But a neuron doesn't just listen, it also speaks. And it speaks with a long, elegant tail called the axon. This axon can be incredibly long, stretching from your spinal cord all the way down to your toe, a single, uninterrupted thread of biological wire. It's an astounding thought that a single cell could span such a distance, carrying a message from one end of your body to the other. The way these cells communicate is a fascinating blend of electricity and chemistry. It's not like flicking a light switch. It's more like a slow, deliberate wave. When a neuron is at rest, it's holding its breath, so to speak, with a slight negative electrical charge. It's in a state of quiet potential. But when it receives enough stimulation from its neighbors through its dendrites, it crosses a critical threshold. This is a moment of decision, a point of no return. Once that threshold is met, the neuron fires. It sends a ripple of electrical energy, a brief pulse, known as an action potential, down its axon. This pulse is an astonishingly fast but quiet event, a spark traveling at speeds up to 120 meters per second. But here's the strange part. The action potential is an all-or-nothing event. A neuron either fires at full strength or it doesn't fire at all. There are no half measures, no whispers of a signal, only the full, clear shout of a message. It is the very definition of a discrete signal. This electrical pulse travels down the axon until it reaches its end, a small bulbous structure called the axon terminal. Here, it meets the dendrite of another neuron, but they don't quite touch. There's a tiny gap, a chasm of 1/1000th of a millimeter, called the synaptic cleft. This gap is one of the most mysterious and profound places in all of biology. It's a place where the electrical signal must translate into a chemical one. The incoming electrical pulse triggers the release of tiny sacs, like microscopic bubbles, filled with chemical messengers called neurotransmitters. These chemicals drift across the synaptic cleft, like silent boats crossing a small river, and bind to specific receptors on the dendrite of the next neuron. It's an elegant, almost poetic form of communication, a dance of molecules across an empty space. What's truly astonishing is the sheer scale and speed of this process. There are over 86 billion neurons in the human brain alone, and each can have thousands of connections to others. This means that at any given moment, there are trillions upon trillions of these tiny chemical conversations happening inside your head. It's a silent, incomprehensible cacophony of information, shaping your every thought, feeling, and action. For a long time, scientists believed that the brain was a static, hardwired machine, like a circuit board. But we now know that it is fluid, dynamic, and constantly changing. Every experience, every new memory, every learned skill slightly rewires the connections between your neurons. The brain is not a machine. It is a constantly shifting and reforming landscape, a living map of your entire life, and it's in this silent, unseen dance that we find some of the deepest mysteries of all. What, for example, is the exact relationship between the firing of these tiny electrical pulses and the feeling of consciousness? How does a trillion-fold conversation of molecules and sparks give rise to the sensation of color, the memory of a loved one's face, or the feeling of awe when you look at the night sky? We can map the activity in the brain when a person feels sad or happy or anxious, but we still don't know why or how that activity becomes the feeling. The truth is, we are still so far from understanding this quiet system. We have only just begun to chart its rivers and valleys. We are like ancient cartographers, drawing rough maps of a world we can only barely perceive. And in the quiet of this night, as you listen, your own universe is performing its beautiful, silent work. Let's take a moment to consider the sheer efficiency of it all. The neuron, for all its complexity, operates on remarkably little energy. Your entire brain, a universe of 86 billion stars, runs on about the same power as a dim light bulb, around 20 watts. It's a level of efficiency that human engineers can only dream of. The neuron, with its elegant form and its precise communication, is a testament to billions of years of silent, biological refinement. It has learned to conserve, to adapt, to find the most direct path to its goal. And what is that goal? To pass on a message, to contribute to the larger symphony. This is the first principle of the quiet nervous system: simplicity, born of infinite complexity. Now, think about the sheer volume of information being processed. A single flash of light, a single note of music, a single texture felt by your fingertips. Each of these is a universe of neural firings. The light from a star travels millions of miles through the vacuum of space, enters your eye, hits a few specialized cells, and is then translated into a silent electrical signal. That signal travels down the optic nerve, a great broad river of millions of axons, until it reaches the back of your brain, the occipital lobe. And there it is decoded, interpreted, and understood as the color of a distant sun. But how? How do we get from a photon of light to the feeling of warmth or the memory of a sunset? This is the central enigma. The scientific explanation, the firing of certain neurons in a certain pattern, feels so incredibly insufficient to explain the richness of the experience. It is a puzzle that stretches from the quantum world of light to the boundless inner world of your mind. And it is not a perfect system. Sometimes, a single neuron, for reasons we do not fully understand, fires when it shouldn't. Or it fails to fire when it should. These tiny miscommunications, magnified across a billion other neurons, can lead to a host of conditions, from a tremor in your hand to profound changes in mood and perception. But for the most part, this system is a marvel of self-regulation and resilience. It finds a way to correct, to reroute, to learn from its own mistakes. A single neuron is a life. A universe of them is a consciousness. And the silent, unceasing work of these tiny cells is the foundation of everything you are. Consider the law of specific nerve energies, a peculiar scientific fact first proposed by Johannes Müller in the 19th century. This law suggests that the quality of a sensation, whether it's sight, sound, or touch, doesn't depend on the stimulus itself, but on the nerve that is stimulated. In other words, if you could somehow stimulate your optic nerve with a strong electrical current, you wouldn't feel a shock. You would see flashes of light. If you stimulated your auditory nerve in the same way, you would hear sounds. This means that your brain doesn't just receive information, it actively interprets it based on where the information is coming from. It's a quiet, internal dialogue, a code that your brain has developed for itself. The light is not in the world. It is an interpretation happening inside your head. The sound is not in the air. It is a resonance in your consciousness. This shifts the entire landscape of reality, doesn't it? It means that your experience of the world is, in a very real way, a deeply personal and subjective creation of your quiet nervous system. This concept, the idea that our reality is an internal construction, is a profoundly philosophical one. It raises a fascinating question. How can we ever truly know that we are perceiving the same world as another person? Your red might be my blue, and we would never know the difference because the labels we have assigned to those sensations are what connect us, not the sensations themselves. This is one of the great, quiet mysteries of existence, hiding in plain sight. We are all living in our own private universe, built of the silent whispers of our neurons. And yet, through language, art, and connection, we manage to build bridges between these universes. We find common ground in the shared mystery. So as you lie back and listen, imagine the quiet universe within you, the dendrites reaching out, the axons extending across vast internal distances, the silent, chemical ballet of neurotransmitters, and the all-or-nothing pulse of the action potential. It's a dance that has been going on since before you were born, and it will continue long after you fall asleep tonight. It is the very engine of your being, and it operates not with a roar, but with a magnificent, patient whisper. This is the first chapter of our story, the tale of the smallest stars in your internal cosmos. Last time, we began with a single neuron, a quiet star in the vast galaxy within you. We watched as it listened through its branching dendrites and spoke with a single, elegant axon. We saw the silent, all-or-nothing pulse of its action potential and the chemical ballet of neurotransmitters crossing the synaptic cleft. But a single neuron, for all its wonder, is just a whisper. To truly understand the story, we must listen to the chorus, to the flowing rivers of thought that form from these countless individual whispers. Tonight, we're going to trace the paths of neural networks, envisioning the brain not as a hardwired machine, but as a vast, flowing delta of consciousness. Think of the brain not as a static building with rigid rooms and corridors, but as a dynamic and ever-shifting landscape of rivers and streams. These are your neural networks. When a group of neurons fires in a particular sequence, it creates a path, a channel for information. The more often this sequence is repeated, the deeper and wider the channel becomes. Imagine a forest path. At first, it's just a few bent blades of grass, but with each person who walks it, the path becomes more defined, more solid. Eventually, it becomes a well-worn trail, a clear route through the wilderness. This is exactly what happens in your brain. When you learn a new skill, say how to play a chord on a guitar, a new neural pathway is forged. The first time you try it, the signals are clumsy and slow. It's like trying to find your way through a dense, unmapped forest. But with each repetition, the pathway becomes more efficient. The neurons that fire together, as the old saying goes, wire together. Their connections strengthen. Their communication becomes more fluent. Eventually, the process becomes so ingrained that you can play that chord without thinking. The once tentative stream of information has become a broad, flowing river of skill and memory. This is the principle of neuroplasticity, a beautiful and profound concept that was, for a long time, dismissed by science. For much of the 20th century, the dominant view was that the adult brain was a fixed entity. We were thought to be born with all the neurons we would ever have, and that our brains, once developed, were incapable of significant change. But this has proven to be a comforting, but ultimately false story. The truth is far more poetic. Your brain is not a finished masterpiece. It is a constantly evolving work of art. It is a soft, malleable tapestry, capable of being rewoven with every experience you have. When a part of the brain is damaged, for instance, other parts can sometimes step in and take over its functions. This is not magic. It is the quiet, tireless work of neuroplasticity. The rivers simply find new routes to the sea, and just as rivers can carve canyons, they can also be rerouted. The human brain is a master of adaptation. Consider the phenomenon of neurogenesis, the creation of new neurons. While it was once thought to be impossible in the adult brain, we now know that it occurs, albeit in a limited way, in a few specific areas. The hippocampus, for example, a seahorse-shaped structure deep in your temporal lobe, is a quiet factory for new brain cells. This area is crucial for memory and learning, and it seems to be in a constant state of gentle, quiet renewal. It is a profound and comforting thought that even in the most ancient parts of your brain, new life is still being born. The way these rivers of thought connect is not random. The brain is organized into distinct but interconnected regions, each with its own specialty. The occipital lobe at the back is a quiet theater for vision. The temporal lobes on the sides are home to the library of memory and the quiet music of sound processing. The frontal lobe, a grand, expansive field at the front of your brain, is the seat of planning, decision-making, and your sense of self. But these are not separate islands. They are all linked by intricate bridges, by vast superhighways of white matter, the axons of millions of neurons bundled together. There's a curious scientific fact about these neural pathways. The speed of the signal can be dramatically increased by a fatty sheath called myelin. Think of myelin as insulation around an electrical wire. The action potential, instead of having to travel down the entire length of the axon, can jump from one gap in the myelin to the next. This greatly increases the speed and efficiency of the signal. It's the difference between walking down a long road and leapfrogging down it. This silent, fatty substance is essential to the smooth functioning of your nervous system, and a breakdown in myelin is at the heart of many neurological diseases. It is a quiet hero of your biology, working unseen to make your thoughts and actions fluid. So, when we look at a brain scan, we are not looking at a list of isolated locations. We are looking at a living, breathing map of connected pathways. When you remember a childhood home, for example, the activity is not just in your memory center. It's a symphony of activity that includes your visual cortex, the parts of your brain that process emotion, and maybe even the areas that remember the feeling of the carpet under your feet. It's not a single memory, but an entire constellation of memories, linked together by these powerful, flowing rivers. This raises a fascinating and deeply personal question. If our neural networks are constantly being rewoven by our experiences, then who we are is not a fixed thing. We are a process, not a product. We are the sum of all the rivers we have carved, all the paths we have walked. This suggests that change is not only possible, but it is an inherent, fundamental part of our biology. We are, at our core, beings of continuous, quiet evolution. The person you are today is a different landscape than the person you were yesterday. And this, to me, is one of the most comforting and beautiful truths we can learn. Physicists still wonder if the universe is infinite. But the truth is, we have a universe of infinite possibility right inside our heads. The number of possible neural connections in a single human brain is so vast, it defies comprehension. It is a number with more zeros than there are stars in the galaxy, or even grains of sand on all the beaches of the world. It is the very definition of a quiet, internal immensity. It is a universe that is both the most common thing in the world, every person has one, and the most unique, never to be repeated, utterly singular thing that has ever existed. The story of the nervous system is the story of you. Not the story of your actions or your words, but the story of your quiet internal landscape. It is a story of countless tiny sparks, weaving together to form a grand tapestry of consciousness. And just as rivers flow into oceans, your individual streams of thought flow into the great, collective ocean of human experience. But it all begins with the silent, unseen rivers flowing through the landscape of your mind. Right now, we have journeyed from the silent, single neuron to the great flowing rivers of neural networks. We've seen how these channels are carved by learning and experience, creating the unique landscape of your mind. But what happens when we try to revisit those rivers? What happens when we try to stand in the same spot twice? Tonight, we're going to delve into the fragile and reconstructive nature of memory, examining how our past is not a permanent record, but a story we continually rewrite. Think of memory not as a dusty library filled with books, each one a perfect untouched record of an event. That's the classic, comforting image, but it's a fiction. The truth is far more mysterious and poetic. Memory is more like a storyteller's stage, where each time you call up an event from the past, you are the one performing the scene. You are the director, the actor, and the scriptwriter all at once. The original event, the moment itself, is just a whisper of a suggestion. The story you tell yourself, the memory you experience, is a fresh creation, woven from the fragile threads of your neural connections. The core scientific concept here is called memory reconsolidation. For a long time, scientists believed that once a memory was formed and stored, it was permanent. It was like saving a file on a computer. You could access it again and again, and it would always be the same. But researchers have discovered something truly astonishing. When you actively recall a memory, it temporarily becomes unstable. The neural pathways that hold the memory are unlocked and become vulnerable to change. During this brief window, you can add new details, change the sequence of events, or even erase parts of the memory altogether. The act of remembering is, in fact, an act of rewriting. This explains so many of the strange and common quirks of memory. It explains why a story you've told 100 times changes ever so slightly with each telling. The details become more dramatic, the dialogue more crisp, the ending more satisfying. It explains why two people can remember the same event so differently. Their initial memories might have been similar, but over time, each person has repeatedly recalled and reshaped the story, influenced by their own biases, emotions, and subsequent experiences. This is why eyewitness testimony can be so notoriously unreliable. The very act of asking a witness to recall what they saw can subtly alter their memory, changing it from a fragile imprint to something else entirely. There is a strange and beautiful paradox here. The very act of trying to preserve a memory is what makes it vulnerable to change. The more you revisit a past moment, the more you edit it. The quiet process of consolidation, where the brain works to lock a memory back into place, is happening all the time, unseen. A quiet scribe meticulously rewriting and filing away new versions of old stories. The memory is not a noun. It is a verb. It is something we are constantly doing. A particularly eerie scientific example of this is the phenomenon of false memories. Researchers have been able to implant vivid, complex memories of events that never happened into people's minds. By simply suggesting a story or showing a doctored photograph, they can lead a person to remember an experience, from getting lost in a shopping mall as a child to riding in a hot air balloon. These false memories often feel just as real and just as vivid as true memories. The neural activity associated with recalling a false memory is almost identical to that of a true one. This raises a profound and slightly unsettling question. How can you ever be truly sure that the memories you hold so dear are actually an accurate reflection of what happened? The truth is, we don't really know for sure. This suggests that our personal history is not a collection of facts, but a narrative we are constantly constructing. Our sense of self is a story, and the quiet, unseen work of memory is the process of telling that story. The brain, with its vast and interconnected networks, is a masterful novelist, weaving a tale of who you are from the raw material of your experiences. It adds foreshadowing and creates character arcs. It builds a coherent, if not always accurate, story. And perhaps this isn't a flaw at all. Perhaps it is a magnificent feature. Maybe the purpose of memory is not to preserve the past, but to help us make sense of the present. So much of who we are is rooted in these quiet, rewritten tales. The quiet confidence you feel about your identity, the narrative of your life's journey, is all built upon a foundation that is far more fluid and dynamic than you realize. It is not a solid monument, but a living garden, where old flowers are replaced and new paths are constantly being trod. This raises an interesting question. If we are continually rewriting our past, can we choose to rewrite it in a way that serves us better? Can we, in a sense, learn to edit our own stories for a more peaceful and fulfilling present? Some therapists and neuroscientists believe the answer is yes. By consciously changing the way we tell ourselves our stories, we can, with patient and gentle work, begin to change the quiet landscape of our brains. And it's a process that happens in silence. It's not something you can consciously command. You cannot simply decide to erase a painful memory. But by engaging with it, by telling a new story around it, you begin the slow, quiet work of reconsolidation. You begin to change the context, to soften the edges, to find new meaning. The memory is not gone, but it is no longer the same. It has been rewoven into the new tapestry of your life. This is the quiet power of your nervous system, a power that goes far beyond simple storage and retrieval. It is the power of silent, constant creation. We have seen how individual neurons whisper to each other, how their collective voices form the flowing rivers of our thoughts and memories, and how those memories are not fixed, but are instead living stories we constantly retell. Now, let's turn our attention to the silent, hidden hand that orchestrates the entire biological symphony of our bodies. Tonight, we're going to explore the autonomic nervous system, the hidden conductor of our body's orchestra, managing everything from our heartbeat to our breathing without our conscious thought. Imagine you are standing in a bustling, crowded city square. The noise, the lights, the sheer volume of activity. It can be overwhelming. This is a good metaphor for your conscious mind. It's the part of you that plans, decides, and navigates the world. But now, look down. Beneath the streets, out of sight, is a vast, complex network of pipes, electrical wires, and communication lines. This unseen system keeps the city running smoothly. It ensures the lights come on, the water flows, and the traffic signals work. This subterranean world is your autonomic nervous system. It is the quiet manager, the tireless administrator of your body's most fundamental functions. The autonomic nervous system is an ancient part of us, a biological inheritance that has been perfected over millions of years. It operates without your permission, without your awareness, and without your conscious control. You do not have to remember to breathe. It remembers for you. You do not have to command your heart to beat. It keeps the rhythm on its own. It is a system of profound trust, where your conscious self has surrendered control to a deeper, more ancient intelligence. This system is divided into two main branches, two counterbalancing forces that work in a beautiful, dynamic equilibrium. The first is the sympathetic nervous system. This is often called the fight or flight system. It is the part of you that responds to stress, to danger, to the sudden demand for action. When you are startled by a loud noise, it is your sympathetic nervous system that immediately floods your body with a rush of adrenaline. It quickens your heartbeat, raises your blood pressure, and diverts blood away from your digestive system and towards your muscles. It's a quiet alarm bell, ringing in a biological language, preparing you for a moment of crisis. Its counterpart is the parasympathetic nervous system, and this is the one we are truly interested in tonight. This is the rest and digest system. It is the quiet, calming force that brings your body back from the brink. It lowers your heart rate, decreases your blood pressure, and promotes digestion. After the alarm bell has rung and the perceived danger has passed, it is the parasympathetic nervous system that whispers, "It's okay. You can relax now." It is the cool hand on a fevered brow, the gentle descent after a sudden climb. And just like a good conductor, it does its work in silence. The two systems are in a constant, quiet dance. Your body is never fully in one state or the other. Instead, there is a constant, subtle interplay, a give and take that responds to the smallest changes in your environment. You are walking down the street and a bus suddenly honks. Sympathetic. It passes and you continue on your way, taking a deep breath. Parasympathetic. This silent, beautiful ballet keeps your body in a state of delicate balance, a state called homeostasis. One of the most fascinating scientific facts about this system is how deeply it is connected to our emotions. The physical sensations of anxiety, the racing heart, the sweaty palms, the churning stomach are not separate from the emotion itself. They are the physical manifestations of an overactive sympathetic nervous system, a biological echo of a mind in turmoil. Conversely, the feeling of calm, of deep relaxation, is not just a mental state. It is a physical reality, a signal that your parasympathetic nervous system is in control. This is why deep breathing exercises, for instance, can be so effective at reducing stress. When you consciously slow your breathing, you are sending a direct signal to your parasympathetic system. Everything is fine. It is safe to relax. You are, in effect, learning to quietly communicate with the most ancient part of yourself. This is a beautiful example of a strange but true feedback loop. While the autonomic nervous system is largely unconscious, you can, with quiet practice, learn to influence it. It's like learning to subtly guide the direction of a great river with just a small push of a finger. The heart rate of a trained meditator, for example, can be brought under a surprising degree of conscious control. We can't tell our hearts to stop, but we can, with time, learn to whisper to them and ask them to slow down. The autonomic nervous system also governs some of the most bizarre and intriguing biological phenomena. Consider the way your body responds to a fever. Your temperature rises, your skin becomes clammy, you shiver. These are all responses orchestrated by your autonomic nervous system in an effort to fight off an invader. Or think about the phenomenon of fainting, where your parasympathetic system can sometimes overreact to a sudden stressor, causing your blood pressure to drop and your body to shut down in a quiet moment of self-preservation. It is a quiet, unconscious defense mechanism, a last-ditch effort to keep you safe. And yet, for all its power and profound influence, the autonomic nervous system remains largely a mystery. We can map its pathways and measure its effects, but the fundamental question remains: where does this unconscious intelligence reside? What quiet force directs the heartbeat of every human being, coordinating a symphony of biological processes with such perfect timing? The truth is, we don't know for sure. It is a testament to the deep well of secrets that still lie within our own bodies, a quiet frontier. just waiting to be explored. So as you lie here, remember the deep, unseen river flowing within you. It is a river of quiet calm and sudden strength. It is the very engine of your life, working without your knowledge or consent. A beautiful, silent conductor, directing the grand orchestra of your being. It is the quiet nervous system at its most fundamental, the silent force that keeps you going, hour after hour, night after night. We have explored the silent administrators of the nervous system, the autonomic branches that keep our bodies humming with life. Now, let's zoom in on the quiet spaces where all the action truly happens. The synaptic clefts. We have already had a brief glimpse of them, those tiny rivers of nothingness between two neurons. Tonight, we're going to slow down and linger there, focusing on neurotransmitters, the chemical messengers that cross the synaptic gap, and their profound role in shaping our moods, dreams, and our very sense of reality. Think of a neuron's axon terminal as a miniature harbor, and the synaptic cleft as the small stretch of water that separates it from the next neuron's receiving dock. The neurotransmitters are the boats, filled with silent messages. When the electrical impulse, the action potential we spoke of, arrives at the harbor, it triggers the release of these boats. They drift across the calm waters of the cleft, and, once they reach the other side, they dock at very specific receptors on the dendrite. The metaphor is a bit like a lock and key. Each type of neurotransmitter has a specific shape that fits only a particular type of receptor. When the key turns the lock, it sends a message to the receiving neuron, either telling it to fire or telling it to stay quiet. This is the quiet language of your brain, a complex and beautiful conversation happening at the molecular level. This is the very essence of synaptic transmission, the fundamental process by which information flows through your brain. The nature of the message, whether it's to excite or to inhibit, is what determines so much of who we are. Some neurotransmitters like glutamate are the exciters. They are the ones who say, go, fire, pass on the message. They are crucial for learning and memory, for strengthening those neural pathways we talked about earlier. Without them, your brain would be a quiet, unmoving sea. Others, like GABA, gamma-aminobutyric acid, are the quiet inhibitions. They are the calming, restraining hand that says, slow down, don't fire. GABA is your brain's natural tranquilizer. It is the reason you don't have constant, runaway electrical activity in your head. The delicate balance between glutamate and GABA is a perfect example of the silent equilibrium that defines the quiet nervous system. Too much glutamate, and you might experience seizures. Too much GABA, and you might feel sedated and lethargic. It is a tightrope walk of molecules, and your brain walks it with an elegant and silent grace. Then there are the more famous neurotransmitters, the ones that often make the headlines. Serotonin, for example, is widely associated with feelings of well-being and happiness. It's a bit of a misnomer to call it the happiness molecule, as its functions are far more complex, but it certainly plays a key role in regulating mood, appetite, and sleep. A low level of serotonin is often found in individuals suffering from depression, and many antidepressant medications work by increasing the amount of serotonin available in the synaptic cleft. It is a quiet, subtle way of turning the volume up on the brain's sense of contentment. Another one is dopamine. This is the molecule of motivation and reward. It's the little whisper that says, do that again. That was good. It is released when you do something pleasurable, whether it's eating a piece of chocolate or achieving a goal. Dopamine is not about pleasure itself, but about the anticipations of pleasure. It's the quiet driver that pushes you to seek out new experiences and repeat satisfying ones. Its misregulation is at the heart of many conditions, from addiction to Parkinson's disease. The truth is, dopamine is not good or bad. It is a powerful force, and the quiet dance of its release and reabsorption is a huge part of what drives you through the day. This silent chemical language can also produce some of the most bizarre phenomena. Consider the simple truth of a placebo. A person is given a sugar pill, but they are told it is a powerful painkiller. Their brain, in its quiet wisdom, releases its own natural pain-relieving neurotransmitters, endorphins. The person feels real relief, all because of a belief. This is the power of the mind's quiet command over its own chemical messengers. The brain can, in a sense, write its own prescriptions. This whole process, from the all-or-nothing electrical signal to the quiet chemical ferry crossing the synaptic cleft and docking at its perfect receptor, is happening trillions of times a second. It is a chaotic, beautiful, and utterly silent ballet. And the fact that we can explain it on a molecular level, yet still have no idea how it gives rise to the conscious experience of feeling happy or sad, is one of the greatest mysteries of our time. We can measure the amount of serotonin in a brain. We can watch a neuron fire, but we still do not know how that chemical signal transforms into the quiet feeling of contentment that washes over you at the end of a long day. Physicists still wonder about the nature of dark matter. But the truth is, we have a far greater mystery right here. The silent, empty space of the synaptic cleft, the bridge between two cells, is a void that holds one of the deepest secrets of our existence. How does a chemical messenger create a memory, a feeling, a thought? The answer is not in the messenger alone, but in the entire quiet conversation. We are the sum of these silent chemical words, and the story they tell is constantly being rewritten, one quiet synapse at a time. We have explored the silent administrators of the nervous system, the autonomic branches that keep our bodies humming with life. Now, let's zoom in on the quiet spaces where all the action truly happens. The synaptic clefts. We have already had a brief glimpse of them, those tiny rivers of nothingness between two neurons. Tonight, we're going to slow down and linger there, focusing on neurotransmitters, the chemical messengers that cross the synaptic gap, and their profound role in shaping our moods, dreams, and our very sense of reality. Think of a neuron's axon terminal as a miniature harbor, and the synaptic cleft as the small stretch of water that separates it from the next neuron's receiving dock. The neurotransmitters are the boats, filled with silent messages. When the electrical impulse, the action potential we spoke of, arrives at the harbor, it triggers the release of these boats. They drift across the calm waters of the cleft, and, once they reach the other side, they dock at very specific receptors on the dendrite. The metaphor is a bit like a lock and key. Each type of neurotransmitter has a specific shape that fits only a particular type of receptor. When the key turns the lock, it sends a message to the receiving neuron, either telling it to fire or telling it to stay quiet. This is the quiet language of your brain, a complex and beautiful conversation happening at the molecular level. This is the very essence of synaptic transmission, the fundamental process by which information flows through your brain. The nature of the message, whether it's to excite or to inhibit, is what determines so much of who we are. Some neurotransmitters, like glutamate, are the exciters. They're the ones who say, go, fire, pass on the message. They are crucial for learning and memory, for strengthening those neural pathways we talked about earlier. Without them, your brain would be a quiet, unmoving sea. Others, like GABA, gamma-aminobutyric acid, are the quiet inhibitions. They are the calming, restraining hand that says, slow down, don't fire. GABA is your brain's natural tranquilizer. It is the reason you don't have constant, runaway electrical activity in your head. The delicate balance between glutamate and GABA is a perfect example of the silent equilibrium that defines the quiet nervous system. Too much glutamate, and you might experience seizures. Too much GABA, and you might feel sedated and lethargic. It is a tightrope walk of molecules, and your brain walks it with an elegant and silent grace. Then there are the more famous neurotransmitters, the ones that often make the headlines. Serotonin, for example, is widely associated with feelings of well-being and happiness. It's a bit of a misnomer to call it the happiness molecule, as its functions are far more complex, but it certainly plays a key role in regulating mood, appetite, and sleep. A low level of serotonin is often found in individuals suffering from depression, and many antidepressant medications work by increasing the amount of serotonin available in the synaptic cleft. It is a quiet, subtle way of turning the volume up on the brain's sense of contentment. Another one is dopamine. This is the molecule of motivation and reward. It's the little whisper that says, "Do that again. That was good." It is released when you do something pleasurable, whether it's eating a piece of chocolate or achieving a goal. Dopamine is not about pleasure itself, but about the anticipation of pleasure. It's the quiet driver that pushes you to seek out new experiences and repeat satisfying ones. Its misregulation is at the heart of many conditions, from addiction to Parkinson's disease. The truth is, dopamine is not good or bad. It is a powerful force, and the quiet dance of its release and reabsorption is a huge part of what drives you through the day. This silent chemical language can also produce some of the most bizarre phenomena. Consider the simple truth of a placebo. A person is given a sugar pill, but they are told it is a powerful painkiller. Their brain, in its quiet wisdom, releases its own natural pain-relieving neurotransmitters, endorphins. The person feels real relief, all because of a belief. This is the power of the mind's quiet command over its own chemical messengers. The brain can, in a sense, write its own prescriptions. This whole process, from the all-or-nothing electrical signal to the quiet chemical ferry crossing the synaptic cleft and docking at its perfect receptor, is happening trillions of times a second. It is a chaotic, beautiful, and utterly silent ballet. And the fact that we can explain it on a molecular level, yet still have no idea how it gives rise to the conscious experience of feeling happy or sad, is one of the greatest mysteries of our time. We can measure the amount of serotonin in a brain. We can watch a neuron fire, but we still do not know how that chemical signal transforms into the quiet feeling of contentment that washes over you at the end of a long day. Physicists still wonder about the nature of dark matter. But the truth is, we have a far greater mystery right here. The silent, empty space of the synaptic cleft, the bridge between two cells, is a void that holds one of the deepest secrets of our existence. How does a chemical messenger create a memory, a feeling, a thought? The answer is not in the messenger alone, but in the entire quiet conversation. We are the sum of these silent chemical words, and the story they tell is constantly being rewritten, one quiet synapse at a time. We have sailed across the rivers of neural networks and navigated the tiny chemical ports of synaptic transmission. We have watched the quiet dancers of our moods and motivations perform their silent ballet. But now, as the night deepens, it is time to move beyond the boundaries of our waking selves. Tonight, we enter the strange and illogical realm of dreams, specifically, the most mysterious phase of all, REM sleep. We will explore the bizarre worlds our minds construct in the absence of external reality. Think of your brain as a great, dark theater. During the day, the stage is bright. The actors are performing their conscious roles and the audience is engaged. But as you drift off to sleep, the lights on the stage dim. The actors of your conscious mind, the planners, the worriers, the reasoners, quietly exit. The theater is still running, but now it is showing a very different kind of film, one made entirely of shadows and strange, fleeting images. This is the state of rapid eye movement, or REM sleep. It is a stage of sleep as active, if not more so, than wakefulness. And it is the stage where most of our most vivid dreams occur. This is a strange scientific paradox. While the brain is wide awake and crackling with activity, your body is in a state of quiet paralysis. This is a crucial defense mechanism. It's a bit like a safety lock. When your brain is conjuring up a dream of running from a mythical beast or flying through the sky, your brainstem sends a signal to your body, essentially saying, "Do not move. You are a ghost right now." This state is called atonia, and without it, you would act out your dreams, likely leading to injury. A breakdown in this system is at the heart of sleepwalking and REM sleep behavior disorder, a rare but fascinating condition where individuals physically live out their dreams. During REM sleep, the brain is actively working to make sense of the vast amount of information it has absorbed during the day. It is like a librarian returning books to their shelves, but with a profoundly creative twist. It takes fragments of your day, a face you saw in a crowd, a few lines of a song, a conversation you had, and it weaves them into a completely illogical, deeply personal, and often highly emotional story. The part of your brain responsible for logic, the prefrontal cortex, is largely dormant during this time. This explains why the narratives of dreams can be so utterly nonsensical. The brain, freed from the constraints of logic and reality, is free to play, to experiment, to create art for an audience of one. There is a less known but utterly fascinating scientific truth about REM sleep. It is not unique to humans. It is found in many mammals and even some birds. This raises an interesting philosophical question. If a dog twitches its paws and barks silently while sleeping, is it dreaming of chasing squirrels? The scientific community widely believes so. This suggests that the quiet, creative process of dreaming is not a uniquely human trait, but a deep biological inheritance that connects us to a much wider tapestry of life. It's a comforting and humbling thought that the animals sleeping peacefully around the world are also having their own bizarre and quiet adventures. Scientists still wonder about the true purpose of a REM sleep. We know that it is crucial for memory consolidation and for emotional processing. It's during this time that the brain seems to process complex emotions and integrate new information into our existing web of knowledge. It's a kind of quiet internal therapy, a time for the brain to sort through the day's emotional clutter. This raises an interesting philosophical question. Are our dreams just a byproduct of this process? Or are they a form of self-exploration? Do we dream to understand ourselves? Or are we simply watching the quiet internal theater of our brains at work? The truth is, we don't really know for sure. The bizarre and fleeting nature of dreams makes them incredibly difficult to study. We are like ancient dream catchers, trying to capture fog in a net. The moment you try to pin a dream down to analyze it, it begins to evaporate. This suggests that the true beauty and purpose of dreams may not be in their narrative, but in the quiet internal work they do. The dream is not the point. The process is. The narrative is simply a ghost, a passing whisper from the deep, creative well of your unconscious mind. So, as you feel yourself drifting towards this quiet theater, remember that you are entering a world built for you alone, a world where the laws of physics are flexible, where old memories can reappear in new and unexpected forms, and where your deepest emotions are allowed to play out on a surreal and silent stage. Your body may be still, but your mind is running free, carving new pathways and telling new stories. It is a testament to the profound, quiet creativity of your nervous system. We have traveled through the fleeting worlds of our dreams and the silent paralysis of REM sleep. We've seen the brain as a storyteller and a weaver of strange, illogical narratives. But even when the mind is at its most free, there is a quiet, diligent force at work, one that keeps us grounded and connected to our physical form. Tonight, we're going to talk about the often overlooked but profoundly important cerebellum, the brain's hidden compass and the silent master of our movements. Imagine the grand stage of your brain, with the cerebral cortex acting as the star of the show. It is the part of you that thinks, plans, and speaks. But tucked away at the back, beneath the great dome of the cerebrum, sits a much smaller wrinkled structure. This is the cerebellum, which means little brain in Latin. It may be small, but it contains more than half of all the neurons in your entire brain. It is a quiet, powerful maestro, and its symphony is the graceful, coordinated art of knowing where you are in space. The primary role of the cerebellum is not in conscious thought, but in the silent, behind-the-scenes work of movement, balance, and coordination. When you consciously decide to reach for a glass of water, that signal originates in your motor cortex, but the journey from thought to action is not a simple straight line. The signal is sent to the cerebellum, which acts as a quiet editor. It takes the rough initial command and refines it, smoothing out the motion, ensuring your hand doesn't overshoot the glass or shake uncontrollably. It's the silent artist that turns a clumsy command into a fluid, elegant movement. Think of it this way. Your cerebral cortex is the general giving the command, "Take the hill." But the cerebellum is the drill sergeant, quietly and meticulously training the soldiers to march in perfect sync, to move with precision and purpose. It is the unsung hero of your quiet life, the reason you can walk without constantly falling, the reason you can bring a spoonful of food to your mouth without missing. It works tirelessly, taking in a constant stream of information from your senses, the position of your limbs, the feeling of the ground beneath your feet, the subtle tilt of your head. And it uses this information to make instantaneous, silent adjustments. There's a fascinating scientific truth about the cerebellum's immense processing power. It is a master of prediction. It learns from your repeated actions and creates a model of what your movements should look like. When you play a sport or learn to play an instrument, you are not just building new neural pathways in your cerebral cortex. You are training your cerebellum to execute complex movements with quiet precision. This is why a professional dancer or a seasoned musician can perform with such effortless grace. Their cerebellum has, through countless hours of silent practice, built a sophisticated and highly efficient program for their movements. The cerebellum's influence goes far beyond physical motion. Recent research suggests it plays a quiet but crucial role in cognition, emotion, and even language. It seems to be involved in the smooth, coordinated flow of thoughts, just as it is involved in the coordinated flow of movement. It helps to ensure that your thoughts don't jump around erratically, but instead follow a logical, coherent path. This raises a new and compelling question. Is the quiet stutter of a speaker's voice, for instance, not just a physical problem, but a manifestation of a deeper struggle within the cerebellum to coordinate the silent river of thoughts? This raises a fascinating and still unanswered philosophical question. For decades, we have associated our sense of self with the great thinking cortex. But if the cerebellum, this quiet, hidden compass, is so deeply involved in the very execution of our thoughts and movements, then what is the true nature of our identity? Is it just the sum of our conscious thoughts? Or is it also the silent, graceful way we inhabit our physical form? The truth is, we don't really know for sure. The more we learn about the brain, the more we see that the self is not a single location, but a grand, interconnected network, with the cerebellum playing a quiet but essential part. A less-known scientific fact is how sensitive the cerebellum is to alcohol. Alcohol consumption can impair the cerebellum's ability to coordinate movement, leading to the clumsiness, slurred speech, and loss of balance that are so characteristic of intoxication. This is a clear, if temporary, demonstration of the cerebellum's quiet but profound importance. When this master of coordination is taken offline, even for a short time, the symphony of our movements descends into chaos. So, as you lie here, remember the silent, hard-working part of your brain that is helping you stay still. It is the master of balance, the keeper of your physical grace, and the architect of your smooth, effortless movements. It works in the dark, behind the scenes, and its quiet diligence is what allows you to move through the world with such fluid, unassuming ease. It is a quiet testament to the idea that the most profound forces in our lives often operate in the silent shadows. We have journeyed from the silent, hidden compass of the cerebellum, which guides our movements, to the illogical worlds of dreams. We have seen how our bodies and minds are governed by forces working in the silent, unconscious background. But this internal world is not an island. It is profoundly connected to the great rhythmic cycles of the universe. Tonight, we're going to explore the body's internal clocks, the circadian rhythms that govern our wakefulness and sleep, and how they connect us to the quiet ancient cycles of the sun and moon. Think of your body as a magnificent, antique grandfather clock with a series of quiet, hidden gears that keep perfect time. This clock is your circadian rhythm. It is a roughly 24-hour cycle of biological processes that are regulated by light and darkness. The master clock for this system, the suprachiasmatic nucleus, SCN, is a tiny, unassuming cluster of neurons located deep in the hypothalamus of your brain. It is like the pendulum of the clock, keeping perfect time for the rest of your body. It is the silent timekeeper, the metronome of your existence. The most powerful external signal that sets this clock is light, particularly the blue light of the morning sun. When light hits the retina in your eye, it sends a direct signal to the SCN. This signal tells the master clock, it is morning. Begin the day. The SCN then sends signals throughout your body, adjusting your internal processes to prepare for wakefulness. Your body temperature begins to rise, your blood pressure increases, and the quiet production of the hormone cortisol begins, giving you a gentle morning jolt of energy. It is a slow, quiet waking, a biological rising with the sun. As the sun sets and darkness descends, the process is reversed. With the absence of light, the SCN receives a new signal. It then tells the pineal gland, a tiny pea-sized gland in the center of your brain, to begin the quiet production of a different hormone, melatonin. Melatonin is often called the sleep hormone, and it is the quiet herald of the night. As it builds up in your system, it sends a gentle, persuasive message to your body and mind. It is time to rest. It is time to wind down. It is a silent lullaby, a chemical whisper that guides you toward slumber. This silent, elegant dance between light, the SCN, and melatonin is the very foundation of healthy sleep. It's a biological rhythm that has been finely tuned over millions of years of human evolution, a deep and ancient connection to the cycles of our planet. This is why spending time outdoors in natural light can be so beneficial for sleep. It helps to set your internal clock to remind your body of the quiet, natural rhythm it was born to follow. Conversely, exposure to artificial blue light from screens late at night can be so disruptive. It sends a confusing signal to your SCN, telling it to be awake just as it is trying to produce the melatonin needed for sleep. It is like a false sunrise, a quiet deception that throws the grandfather clock of your body out of whack. There is a fascinating scientific truth about circadian rhythms that extends beyond sleep. Almost every cell in your body has its own tiny internal clock. These peripheral clocks govern the quiet, rhythmic activity of your organs, from your digestive system to your immune system. They all follow the lead of the master clock, the SCN, but they have their own unique rhythmic dances. This is why, for instance, a medicine you take in the morning might have a different effect than the same medicine taken at night. The quiet, rhythmic ebb and flow of your body's chemistry is constantly changing. The truth is, we don't fully understand the elegant and complex interplay between the master clock and all the little clocks in our organs. We know they are synchronized, but the exact mechanism of their communication remains a bit of a mystery. It raises an interesting question. How does the SCN, a small cluster of cells in the brain, send a quiet, commanding message to a cell in your liver or your kidney, telling it what to do and when to do it? It is a biological symphony of such complexity that it defies our full comprehension. This quiet internal rhythm is a beautiful example of our deep connection to the cosmos. Your body, in its silent wisdom, is listening to the sun. It is a testament to the fact that we are not just collections of cells, but beings woven into the great rhythmic tapestry of the universe. The simple act of falling asleep is not just an individual event. It is a participation in a cycle as old as the planet itself. It is a quiet return to the rhythm of darkness and light, a biological memory of a time when there were no screens, no artificial lights, and no distractions. Just the quiet descent of the sun and the rising of the moon, a silent signal that it was time to rest. So, as you feel yourself becoming heavier, quieter, and stiller, remember the tiny silent pendulum swinging in your brain. It is keeping time for you, guiding you toward a restful state, a quiet, biological return to your own ancient rhythm. It is the quiet heartbeat of time, keeping you in sync with the universe. We have followed the body's internal clocks, the quiet rhythms that connect us to the sun and moon. We have seen how light and darkness orchestrate our internal state of wakefulness and sleep. Now, let's descend even deeper into the mystery of sleep itself, moving beyond the dream-filled landscape of REM into the silent, profound depths of non-REM sleep. This is where the brain and the entire nervous system performs its most crucial and quiet acts of maintenance. Think of your brain during the day as a bustling, vibrant city. The lights are on, the traffic is moving, and all the systems are working at full capacity. But at night, the city doesn't just go dark. Instead, a different kind of workforce takes over. The noisy traffic of conscious thought slows to a trickle, and a quiet, diligent crew gets to work. This is a good metaphor for non-REM sleep, which is divided into 3 distinct stages, from light dozing to a deep, unconscious state. In these deeper stages, your brain's electrical activity slows dramatically, replaced by long, slow, synchronized waves. These are called delta waves, and they are the signature of the deepest, most restorative sleep. During this quiet, deep sleep, something truly remarkable happens. The brain washes itself. For a long time, scientists wondered how the brain, with its countless neurons and complex connections, cleared out the waste products that build up during the day. We now know the answer is a unique and elegant system called the glymphatic system. Think of it as a silent, invisible sanitation crew. As you enter deep sleep, the brain cells actually shrink by up to 60%, creating tiny channels between them. Cerebrospinal fluid, a clear watery substance that surrounds the brain and spinal cord, is then quietly pumped through these channels, effectively flushing out toxic proteins and waste products that have accumulated during the day. It is a silent, nightly cleansing, a crucial process that keeps your brain healthy and functioning. One of the most important waste products flushed away is beta amyloid, a sticky protein that, in high concentrations, is associated with Alzheimer's disease. The discovery of the glymphatic system was a major breakthrough in neuroscience because it provided a quiet, physiological reason for why sleep is so important for long-term cognitive health. It suggests that sleep is not a luxury. It is a fundamental, biological necessity. Without this nightly cleansing, the brain would slowly become clogged with its own byproducts, a quiet city suffocating on its own waste. The deepest stages of non-REM sleep are also when your body does much of its most important physical repair work. During this time, the body releases a surge of growth hormone, which is essential for cell repair and regeneration. It is a quiet, powerful surge of life-sustaining energy, working unseen in the background. The immune system also gets to work, producing proteins called cytokines that help fight off infection and inflammation. This is why a lack of sleep can leave you so vulnerable to illness. The quiet, nightly army of your immune system is simply not given the time to prepare for battle. A less-known scientific fact is that the brain's ability to learn is also deeply tied to non-REM sleep. While REM sleep is crucial for emotional and memory integration, deep non-REM sleep is where the brain consolidates and strengthens new factual information and motor skills. This is why, after learning something new, a good night's sleep can make the information feel so much more ingrained in your memory. It is a quiet, internal rehearsal, a way of filing away the day's lessons into the great library of your mind. This raises a fascinating and still unanswered philosophical question. During these deepest stages of sleep, your conscious mind is entirely gone. There is no awareness, no sense of self, only the quiet, rhythmic humming of your brain's cleansing and repair systems. So, where does your consciousness go? Does it simply wink out of existence for a few hours, only to be turned back on in the morning? Or is it still there, a quiet ghost in the machine, simply detached from the physical processes it normally inhabits? The truth is, we don't really know for sure. The nature of consciousness during these quiet, deep hours remains one of the most profound and mysterious frontiers of science. So, as you feel yourself drifting into the quiet deep, remember that you are entering a state of profound restoration. Your mind will become still, your body will become calm, and the silent, diligent forces of your nervous system will get to work, cleaning, repairing, and renewing you for the day to come. It is a quiet trust, a surrender to a deeper, more ancient intelligence that knows exactly what you need. It is the deep sea of sleep, and you are quietly plunging into its dark, peaceful waters. We have plunged into the quiet depths of non-REM sleep, where the brain washes and repairs itself in a silent, nocturnal ritual. We've seen how the nervous system, with its electrical and chemical signals, orchestrates so much of our inner world. But there is another, parallel communication network at work, one that is slower, more deliberate, and no less profound in its influence. Tonight, we will explore the endocrine system, a silent language of hormones that shapes our growth, our moods, and our quiet journey through life. Think of the nervous system as a great high-speed telegraph network. It sends messages in milliseconds, a rush of electricity and neurotransmitters. The endocrine system, in contrast, is more like the postal service. It sends its messages, the hormones, through the bloodstream. They travel at a much slower pace, but their effects are often far-reaching and long-lasting. Hormones are the quiet, eloquent poets of our biology, and their words are written on every cell in our bodies. The endocrine system is a constellation of glands, each one a tiny silent star, producing its own unique messengers. The pituitary gland, a pea-sized structure at the base of your brain, is often called the master gland. It acts as a kind of grand central station, receiving signals from the brain and then sending out its own hormonal commands to other glands throughout the body. It whispers to the thyroid gland in your neck, telling it to regulate your metabolism. It speaks to the adrenal glands on top of your kidneys, urging them to produce adrenaline in moments of stress. And it communicates with the gonads, the ovaries and testes, governing the quiet, profound processes of growth and reproduction. Hormones, unlike neurotransmitters, do not act on a single cell. They travel far and wide, searching for specific receptors on a multitude of cells, tissues, and organs. A single hormone can have a cascade of effects, like a ripple spreading across a still pond. A surge of cortisol, for instance, from your adrenal glands in a moment of panic, not only increases your heart rate and blood pressure, but also tells your immune system to quiet down and diverts energy away from your digestive system. It is a silent, global command. A fascinating scientific truth about the endocrine system is its intricate feedback loops. It's a system of checks and balances, a kind of elegant, quiet conversation. When the brain sends a signal for a certain hormone to be released, the presence of that hormone in the bloodstream eventually sends a signal back to the brain saying, "Okay, we have enough. You can stop now." This silent, self-regulating mechanism ensures that our bodies are always in a state of quiet, delicate balance. When this feedback loop is disrupted, it can lead to a host of health problems, from diabetes to thyroid disorders. This quiet chemical language also plays a profound role in our emotions and our social bonds. Consider the hormone oxytocin, often called the love hormone or the cuddle chemical. It is released in moments of intimacy, trust, and social bonding, from the act of childbirth to a simple hug. Oxytocin quietly reinforces feelings of connection and empathy. It is a slow, silent whisper that tells you, "You are not alone." It is a beautiful example of how a tiny molecule can have such a profound influence on our sense of belonging and our capacity for love. A less-known scientific example of the power of the endocrine system is the effect of leptin and ghrelin. Leptin is a hormone produced by fat cells that tells your brain when you are full. Ghrelin is a hormone produced in the stomach that tells your brain you are hungry. They are a quiet, chemical conversation between your body and your mind, governing one of the most fundamental aspects of your survival. But this is not a perfect system. A lack of sleep, for instance, can increase ghrelin and decrease leptin, making you feel hungrier and less satisfied. A quiet deception that can lead to overeating. The truth is, while we have mapped out many of the glands and hormones, the true complexity of their interactions remains a great unsolved mystery. We still don't fully understand how the intricate dance between our nervous system and our endocrine system gives rise to the unique tapestry of our personality and our moods. We know that emotions can trigger the release of hormones, and that hormones can in turn shape our emotions, but the precise nature of that dialogue remains elusive. It is a quiet, ongoing conversation that we can only listen in on, never fully comprehend. So, as you rest, remember the silent, patient couriers of your endocrine system. They are the chemical messengers of your very being, shaping your growth, your temperament, and your quiet connections to others. They are a testament to the fact that the most powerful forces in our lives often operate not with a flash of lightning, but with a slow, deliberate whisper. We have listened to the quiet, slow language of hormones and their profound influence on our bodies and minds. We have seen how these patient messengers shape everything from our moods to our metabolism. But what about the moments that transcend the mundane? What about the quiet, profound experiences that take our breath away? Tonight, we're going to consider the neurobiology of wonder and awe, linking the brain's reward centers to our capacity to find beauty in the universe, from a star to a single cell. Think of the experience of awe. It's that feeling you get when you stand at the edge of a great canyon, or look up at the vast expanse of the night sky, or listen to a powerful piece of music. It is a quiet, powerful moment when your sense of self shrinks and you feel connected to something much larger than you are. For a long time, awe was considered a purely spiritual or philosophical experience, but scientists are now beginning to understand its biological underpinnings, the silent dance of neurons and neurotransmitters that creates this feeling. The core scientific concept here is the interaction between the brain's default mode network, DMN, and its reward system. The DMN is a network of brain regions that is most active when you are not focused on an external task. It is the part of your brain that is responsible for self-referential thought, for daydreaming, for thinking about your past, for worrying about your future. It is the network of me. When we experience awe, the activity in the DMN dramatically decreases. The part of the brain that is usually so focused on yourself, on your own little world, suddenly goes quiet. It is a moment of profound psychological disarmament. At the same time, the brain's reward system, which is a network of structures that includes the nucleus accumbens, becomes highly active. This system is normally associated with the anticipation of pleasure, like the dopamine rush we talked about earlier. But in moments of awe, it is not just about pleasure. It is about a sense of profound meaning and connection. It's a feeling that says, this is important. This is beautiful. This is something to be cherished. The reward is not a fleeting pleasure, but a deep and quiet sense of significance. A fascinating scientific truth about this experience is its prosocial effects. Studies have shown that people who experience awe are more likely to be generous, to be more compassionate, and to feel a greater sense of connection to others. It seems that the quiet act of humbling the self and activating the reward centers in this particular way has a gentle, profound effect on our behavior. It quietly encourages us to step outside of our own narrow self-interest and to see ourselves as part of a larger, interconnected whole. This is a beautiful example of how a quiet, internal process can have a tangible and positive effect on the world around us. Consider a less-known example of awe, one that is perhaps even more mysterious: the feeling of frisson or skin orgasm, a quiet shiver that runs down your spine when you hear a beautiful piece of music or see a powerful scene in a film. Scientists still don't fully understand why this happens. It's a sudden, quiet surge of emotion that seems to bypass all the usual logical processes. It is a moment when the body and the mind are in perfect, silent synchronicity, and the beauty of the external world is met with a physical response that is both immediate and deeply personal. It is the body's own quiet, physical gasp of awe. This raises an interesting question. Is our capacity for awe an evolutionary advantage? Did the quiet experience of feeling connected to something larger than ourselves help our ancestors to form stronger tribes, to cooperate, and to survive? The truth is, we don't really know for sure, but the fact that this feeling is so universal, so powerful, and so biologically rooted suggests that it is not a mere accident of consciousness. It is a fundamental quiet part of what makes us human. The quiet pursuit of science and the quiet experience of awe are, in a beautiful way, two sides of the same coin. The scientist, in their quiet pursuit of knowledge, is trying to understand the intricate workings of the universe. The person who experiences awe is simply standing in quiet admiration of those workings. Both are a testament to the profound beauty and mystery of existence, and both are made possible by the quiet, tireless work of your nervous system. So as you settle into the quiet of the night, remember that your brain is not just a tool for problem solving, it is also an instrument for experiencing beauty. It has a quiet, built-in capacity for wonder, a network of neurons that is waiting to be humbled and inspired. And the simple act of lying still and listening to the quiet of the world is, in a way, a small, gentle act of awe. It is a quiet acknowledgement that your own existence is a mystery as profound as any star in the night sky. We have explored the neurobiology of awe, the quiet moments when the self-referential mind goes silent and we feel a deep connection to something larger than ourselves. But what about the moments when the quiet is broken? What about the sudden surges of emotion that can feel overwhelming? Tonight, we're going to examine the prefrontal cortex and its role in emotional regulation, the quiet voice of reason that can calm the storms of the limbic system. Imagine a crowded theater, the stage filled with a cast of actors representing all of your emotions: fear, anger, joy, sadness. This stage is your limbic system, an ancient and powerful part of the brain that is responsible for processing emotions and memories. The amygdala, a small almond-shaped structure deep in the limbic system, is the master alarm bell. When it perceives a threat, whether real or imagined, it rings loudly, sending a cascade of signals that trigger the fight or flight response we spoke of earlier. It is the impulsive, passionate, and sometimes irrational part of you. Now imagine an old, wise theater critic sitting quietly in the back row, taking notes and observing the scene with a calm, discerning eye. This critic is your prefrontal cortex. Located at the very front of your brain, right behind your forehead, the prefrontal cortex is the most recently evolved part of the human brain. It is the seat of your executive functions, planning, decision-making, social behavior, and, most importantly, for our discussion tonight, emotional regulation. The prefrontal cortex and the limbic system are in a constant, quiet dialogue. When the amygdala rings its alarm bell, the prefrontal cortex has the capacity to listen, to observe, and to send a quieting signal back. It's a bit like an older sibling calmly saying, "It's okay. I see you are scared, but look at the facts. The threat is not real. You're safe." It is a silent, gentle, and often difficult act of self-soothing. This is the neurological basis of a quiet, intentional breath when you feel stressed, or the ability to count to 10 before you say something you might regret. A fascinating scientific truth is that this relationship is not always equal. In moments of extreme stress or panic, the amygdala can completely hijack the prefrontal cortex. It's as if the actors on the stage become so loud and so frantic that the quiet voice of the critic in the back row is completely drowned out. This is a quiet but powerful neurological reality. It explains why it can be so hard to think logically when you are consumed by fear or anger. The emotional part of your brain is in control, and the rational part has for a moment been silenced. A less known but profoundly important fact is that this relationship between the prefrontal cortex and the limbic system is not fixed. It can be strengthened with practice. This is the physiological basis of mindfulness and meditation. When you practice these quiet disciplines, you are not just relaxing. You are actively strengthening the neural pathways between your prefrontal cortex and your limbic system. You are, in effect, teaching the wise old critic to have a stronger and more effective voice. You are training your brain to choose a quiet, calm response over an impulsive, emotional one. This is why a regular meditation practice can, over time, lead to a greater sense of peace and emotional stability. It's a quiet, patient rewiring of your own brain. The neurobiology of this is beautiful and complex. The prefrontal cortex can use neurotransmitters like GABA to inhibit the activity of the amygdala. It can send a quiet chemical message that says, "Calm down, everything is under control." It is a testament to the fact that the most profound changes in our lives often occur at the smallest, most quiet level, a single molecule, crossing a single synapse, and making a single quiet suggestion. This raises an interesting and deeply personal question. If our ability to regulate our emotions is a muscle that can be strengthened, then our quiet journey toward inner peace is not just a spiritual one. It is a neurological one. It is a quiet, biological choice we can make every day. The truth is, we are not just victims of our emotions. We are the quiet architects of our emotional landscape. We have the capacity, with gentle and patient work, to build a quieter, calmer world inside of ourselves. So, as you feel the quiet of the night, remember the quiet voice of reason in your own head. It is your most powerful tool for navigating the storms of life. It is the quiet critic that helps you to find your balance, to stay grounded, and to respond to the world with grace and compassion. It is the architecture of calm, and it is a fundamental part of your quiet nervous system. We have examined the architecture of calm, the quiet dialogue between our prefrontal cortex and our limbic system. We have seen how our most noble qualities, our compassion, our patience, are rooted in a quiet, biological conversation. Now let's widen our gaze from the small world inside our skulls to the grand, impossible scale of the cosmos. Tonight, we will draw parallels between the structure of the nervous system and the large-scale structure of the universe, seeing the universe not just as a cold, empty expanse, but as a vast, quiet mind. Think about the human brain, a place of trillions of connections, a dense web of neurons linked by the glowing tendrils of their axons. We have described it as a galaxy, a universe. But what if the reverse is also true? What if the universe is itself a kind of brain? This is not a new philosophical idea, but recent scientific discoveries have given it a fresh, compelling resonance. Consider the largest scales of the universe. When astronomers peer into the vast darkness with powerful telescopes, they do not see a random distribution of stars and galaxies. Instead, they see a cosmic web, a grand network of galactic filaments and clusters of matter, separated by immense voids. These filaments are made of billions of galaxies, stretching across distances of hundreds of millions of light years. When scientists create computer simulations of the evolution of the universe from the Big Bang to the present, a structure remarkably similar to a brain's neural network emerges. It is a quiet, profound coincidence, or perhaps a clue. The scientific concept here is that of fractal patterns. A fractal is a pattern that repeats itself at different scales. A single tree branch, for example, often has a smaller version of itself sprouting from its side, and that smaller branch has even tinier versions, all the way down to the veins of a single leaf. The same is true for the human circulatory system, which branches from a large artery to countless capillaries. And as it turns out, the cosmic web and the human neural network also seem to follow this quiet, self-similar pattern. The intricate branching of a single neuron's dendrites is a pattern repeated in the branching of neural pathways, which is in turn mirrored in the grand, quiet architecture of the universe itself. A fascinating scientific truth is the comparison in scale and complexity. The human brain contains approximately 86 billion neurons. The observable universe is estimated to contain a similar number of galaxies, approximately 100 billion. The energy efficiency is also uncannily similar. We noted that the human brain runs on a mere 20 watts of power. The cosmic web, a structure of incomprehensible size, also operates on principles of extreme efficiency. It is a quiet, elegant system that organizes itself with the least amount of energy required, as if following a cosmic law of conservation. This raises a fascinating and deeply philosophical question. Is this just a beautiful coincidence? Are these two vastly different systems, the human mind and the cosmic web, just two examples of a quiet, universal pattern? Or is there something more profound at play? Physicists still wonder if the universe has a consciousness, if it is in some way alive. But the truth is, we don't really know for sure. The fact that the most complex structure we know of, the human brain, and the largest structure we can see, the cosmic web, share such a fundamental architectural similarity is a quiet mystery that continues to humble and inspire us. Consider a lesser-known scientific fact that deepens this mystery. The way the brain processes information, as we've discussed, is through a silent, collective conversation. No single neuron holds a memory or a thought. The information is distributed across a vast network. This is also true of the cosmic web. The filaments and galactic clusters do not act as isolated entities. They are a deeply interconnected network, their movements and evolution influenced by the actions of every other part. They are a grand, quiet collective in a dance as old as time itself. So, as you lie here, remember that the quiet universe within you is not separate from the universe outside of you. Your neurons, in their branching and connecting, are whispering the same quiet language as the stars and the galaxies. You are not a spectator of this universe. You are a participant. You are a small, quiet part of a grand, beautiful design. The silent immensity of the cosmos is not something external to you. It is mirrored in your own mind, in the quiet depths of your own being. It is the universe within, a testament to the fact that the most profound truths are often found in the quietest of places. We have traveled from the single neuron to the quiet depths of sleep, from the unseen conductors of our bodies to the vast, mirroring structure of the cosmos. We have explored the way our minds create and recreate memory, the hidden architects of our movements, and the quiet architecture of our calm. We have seen how the universe outside of us is reflected in the universe within. Now it is time to bring our journey full circle. Tonight, we conclude by returning to the very beginning, to the single resting neuron, and leaving the listener with the quiet mystery of their own existence. Remember how we began, with that single cell holding its breath, a tiny self-contained universe of potential. It was in a state of quiet rest, with a slight negative electrical charge, waiting. This state of quiet readiness, of potentia, is the very essence of your being when you are at peace. It is not an absence of activity. It is a waiting, a holding, a silent anticipation of a signal that may or may not come. This is the quiet nervous system at its most fundamental, stripped of all its noise and complexity. It is the simple, elegant silence that precedes all thought and all action. Think of a neuron that has just fired. It has sent its message, crossed its great chasm, and a silent electrical ripple has traveled down its axon. But it cannot fire again immediately. For a brief, crucial moment, it enters a refractory period, a time of enforced rest. It is a moment of quiet, biological recalibration. It is a time for the neuron to recharge its electrical batteries, to reset itself, and to prepare for the next possible signal. Without this quiet moment of rest, there could be no communication. There would only be a chaotic, unending cacophony of sound. The most powerful act a neuron can take, in a way, is to do nothing, to be still, to listen. This is a beautiful and simple metaphor for our lives. In our hurried, noisy world, we often forget the importance of the refractory period. We try to be constantly firing, constantly moving, constantly producing. We forget the profound power of quiet rest, of patient listening, of doing nothing at all. But just as the neuron cannot fire without resting, we cannot truly live without giving ourselves over to moments of quiet stillness. A quiet nervous system is not a system that is asleep or broken. It is a system that is at its most potent, its most powerful. It is holding its breath, full of quiet potential, ready for whatever comes next. A less-known scientific fact is how the glial cells, the quiet, unassuming support staff of the brain, are now believed to play a much larger role than we ever imagined. For decades, they were thought to be just the glue that held the neurons together. But we now know they are active participants in the conversation. They clean up waste, they provide nourishment, and they subtly regulate the signals between neurons. They are the quiet janitors and caretakers of the brain, and they are essential to its health. This is a beautiful reminder that the most important work is often the quietest work, and the most essential people in our lives are often the ones who work silently behind the scenes. This raises a final, beautiful, and deeply personal question. What is the nature of the space between the thoughts? What is the quiet that exists in the moments between our conscious perceptions? We can explain the neurons, we can explain the neurotransmitters, and we can map the pathways. But we cannot explain the quiet. The truth is, the quiet that precedes thought, the stillness that exists between the beats of our heart, the peaceful moments between our breaths. This is the great unsolved mystery of our existence. It is the canvas upon which our lives are painted. But it is not a thing we can hold or define. It is simply the quiet. So we have come back to where we started, to the quiet, still center of it all, to the simple, biological truth of a single, resting cell. This is the foundation of every thought you have ever had, every memory you have ever held, every dream you have ever woven. It all begins in the stillness, in the quiet, in the holding of a breath. It is the final and most profound secret of the quiet nervous system. Our journey has come to a gentle close. We have wandered through the intricate forests of your mind, sailed the chemical rivers of your emotions, and gazed out at the cosmic web reflected in your neurons. It has been a quiet, winding path, and I hope it has brought you a sense of calm. The story we have told is not just a scientific one. It is a human one. It is the story of your own quiet existence. I'd like to gently ask one last time, where is the place you're staying now? The time in that place, at this very moment, how is it flowing? Just for a moment, let go of any remaining thought and gently turn your attention to the quiet stillness in your room. Feel the weight of the blanket, the softness of the pillow, the slow, rhythmic rising and falling of your own breath. The world outside is a torrent of noise, but inside, there is always this quiet harbor, this place where you are now, this quiet moment you are sharing with me, is a testament to the fact that peace is not something you have to find outside yourself. It is a place you can always return to. And it is there, in that quiet place, that the most profound work of your nervous system truly begins. So let's gently release the story now. Let the words slowly fade like ripples on a still pond. Just rest. There is nothing more you have to do tonight. Sleep well, my companion, wherever and whenever you are. Sweet dreams.